We think of urinary system as a matter of water goes in and pee goes out. Well, we didn't take any information about it, so basically you don't know what system we're going to discuss today. Urinary system starts functioning after digestion, and a lot of chemicals are left in our body. And liver plays a tremendous role in directing dead cells and chemical leftovers through the digestive system and urinary system. But your liver can't escort waste of your person. Much of the chemicals needs to be sorted out before it is sent on a one-way travel to the bladder. So one system goes in and that is your urinary system. But its main purpose, what we are going to discuss today, is how it filters toxins. This system, specifically the kidneys, has all sorts of important roles like regulating your water volume, concentrations, and pH level, influencing your red blood cell production and blood pressure. But its main purpose, which what we are going to discuss today, is how it filters toxic leftovers from your blood. Our discussion will involve the how, why, and what of your pee. Now you all probably know that kidneys are filters, and you may imagine it like a piece of glass straining the solid substance in a liquid. But it is in fact the opposite of what you are thinking. Most in our blood is removed by the kidneys. Then our body puts back what it needs to hold on to before it is sorted in the bladder. It's kinda like this. You don't clean out your fridge by just taking out the rotten fruits and fuzzy leftovers. Instead, you take all of them out and sort what things goes back into the fridge and what goes into the trash. That is how your urinary system cleans you up. So today, imagine you have eaten an egg. The digestive system did its thing, and all proteins was hydrolyzed into amino acids, which were absorbed by my blood and sent all over my body to build and repair cells. It's a beautiful thing, but not without the consequences, because metabolizing nutrients, especially protein, makes a mess. You may remember that amino acids are unique in that they have nitrogen in their amine groups. And because we can store amino acids, extra ones gets processed into storable fats or carbs. But the amine groups isn't used in those storage molecules, so it's converted to NH3 or ammonia, which happens to be toxic. So the liver converts the ammonia into a less toxic compound called urea, which our kidney filters out into our pee. Taking out of the nitrogenous trash is one of the urinary's biggest jobs. Its other major duty is to regulate the balance of salt and water in your blood. Your kidneys are a pair of dark red fist-sized bean-shaped organs that sits on each side of each spine against the posterior body wall. Kidneys are retroperitoneal, which means they lie between the dorsal walls of the peritoneum, the membrane that surrounds the abdominal cavity, rather than inside of the cavity itself, like your intestine and stomach do. Each kidney has distinctive layers, beginning with the outermost cortex. Beneath that is the medulla, a set of cone-shaped masses of tissues that secretes urine into tiny sac-like tubules. And finally, the innermost layer is the renal pelvis, a funnel-shaped tube surrounded by smooth muscles that uses peristalsis to move urine out of the kidney into the ureter and into the bladder. The kidney's main job is to filter blood continuously. In fact, they hold over 20% of your total blood volume. This means kidney filters about 120 to 140 liters of blood every day. As they enter the kidney, renal arteries branch many times. ending in tons of little capillary groups. So kidney isn't just one big filter. Instead, each one is made up of about a million twisting microscopic filtering units called nephrons. Structurally and functionally, nephrons are where the real business of blood processing, which, like pee making, begins in three steps: filtration, reabsorption, and secretion. Each nephron consists of a round renal corpuscle that resides up in the cortex, followed by the long and winding renal tubule that loops around between the cortex and the medulla. The outer part of the corpuscle is a cup-shaped feature called glomerular capsule, because inside it there's a whole tangle of capillaries called the glomerulus that forms the Latin word for ball of yarn, which is pretty much what it looks like. And the endothelium of these capillaries is very porous, so they allow lots of fluid, waste products, ions, glucose, and amino acids to pass from the blood into the capsule. But they block out bigger molecules like blood cells and proteins, so they stay in the blood and exit through the peritubular capillaries, also known as the vasa recta. Even though it looks like just a tube, it has three major parts, some of which are permeable to certain substances but not others. First is the proximal convoluted tubule, or PCT, which is about as convoluted looking as its name suggests. Then, the tube drops into a dramatic hairpin called the nephron loop, or the loop of Henle, and finally, it ends in the DCT, or distal convoluted tubule, which empties into a collecting duct. Just like with your small intestine, the long curly shape of the nephron provides more time and space for it to reabsorb whatever usable stuff it can. And this path also allows the parts of the tubule that are towards the end to have an effect on process that takes place closer to the beginning as they pass each other, because a lot of the stuff that winds up in the tube are valuable commodities like ions and glucose and water. So let's trace the whole process. Starting at the top with the proximal convoluted tubule, or PCT, the walls here are made of cuboidal epithelial cells with big mitochondria that makes ATP to power pumps that pulls lots of sodium ions from the filtrate using active transport. These cells also covered in microvilli that increase their surface area and helps reabsorb much of the good stuffs from the filtrate and back into the blood. The remaining filtrates process from the PCT into the top, the loop of Henle, which starts in the cortex, dips into the medulla before coming back into the cortex. This is mainly by actively pumping out salts in the ascending limb. This creates some very salty interstitial fluid in the medulla, so when new filtrate comes down the descending loop in front of it, water passively turns out and turns into the super salty interstitial space. Needless to say, this is super important because if we peed out all the water that went into our kidney, we would have died of dehydration. As we move out of the loop of Henle into the distal convoluted tubule and into the collecting duct, the remaining filtrate is now officially urine. But there's more component that we have to squeeze the most out of before we excrete the stuff, and it is urea. Though we think of urea as a waste, the kidneys actually need it. They use it to ramp up the concentration gradient earlier in the process, making the medulla even saltier for the filtrate. So, in the final steps, after the filtrate leaves the distal convoluted tubule or DCT, heat enters the collecting duct which rubs back into the medulla. So there's essentially a traveling pool of urea that escapes the urine, finds its way back into the loop of Henle, and then runs the whole course again. That is an ammonia-scented cycle called urea recycling. Now all that's left is a kind of blast all to selectively sneak out any extra waste like hydrogen, potassium, and certain organic acids and bases using active transport. This is called tubular secretion, and it transports only select kinds of waste that have already made their way into the blood, that it is the peritubular capillaries ready to leave the kidneys. This step is like emptying your pockets of any last wools of tissues or crumpled receipts as you're walking a bag of trash to the curb. And that's how your kidney cleans up the mess left on your body after metabolizing the food. So if you thought that your kidney were just a kind of some fine mesh that filtered out bad stuff, now you know that's not true.